The following question is on buffers. As usual, I'm going to look at the data, so we know the pH is 5.0. But then we have sodium ethanoate. It's really important to realize this is a salt. And we have the volume of it and the concentration. Therefore, even if you don't know what to do in this question, just work out the number of moles here. That might give you a mark. So that's 0.40 cubed times 0.2, which equals 0.08 moles. They give us as well the Ka of ethanoic acid, and they want us to calculate the mass of the salt that we need to prepare the buffer solution. And the total volume is going to stay constant at 400 centimeter cube. Okay, so if we want to know the mass, probably to know the mass we need this equation, which is mass equals the number of moles times MR. The MR is easy to get because we know the formula of sodium ethanoate. However, we don't know the number of moles. How can we calculate that? Probably from the following equation, which is number of moles equals concentration times volume. We know the volume, which is 400 centimeter cube, but we don't know the concentration. Where can we get the concentration from? Probably from the Ka expression. So the Ka equals concentration of protons times concentration of conjugate base, all of it divided by the concentration of acid. We want to calculate the concentration of the conjugate base, and they give us the pH, which is 5. That means that the concentration of protons equals 10 to the power of minus pH, so that's 10 to the minus 5 mole per dm cube. We know the concentration of the acid, which is 0.2, and we know the Ka, so we can find out the concentration of salt. So concentration of salt of conjugate base, which is the same, equals the Ka times concentration of acid divided by the concentration so divided by the concentration of protons. And now we substitute the variables by their value, so Ka is 1.75. I'm going to choose a different color. The power of minus 5 times concentration of acid, which is 0.2, divided by concentration of protons, which is 10 minus 5. So again, 10 minus 5 and 10 minus 5 cancel out. So we have to do 1.75 times 0.2. That equals 0.35 moles per dm cube. So that's the concentration we are here now. Then if we multiply the concentration by the volume, 0.35 times the volume, which is 0.4, that equals 0.14. And now we have the moles. And now to calculate the mass, equals the moles, which is 0.14, times the molar mass, which is 82. And that gives you the final answer, which is 11.48. And that's it. Thing to remember here is when you have a question on buffers, you will have to use the Ka expression, and you have to work a little bit backwards, and that's all.